laptop, in your computer, and you are good to go.
Excuse me, Professor, I got a quick question.
Sure,
I'm exactly like the person who spoke a while ago. This is my first class, yeah. How will I be able to watch last week's recording? Like I can't, like I know you said it's going to be uploaded, but I don't see it.
No. So actually, I'm not recording my session, my labs. All right. So all the necessary material is already on eCentennial.
Okay.
And eventually, if I'm presenting something different that is on eCentennial, I will post it supplementary on the top of what you already have on eCentennial. All right.
Thank you
for
very
example,
much, Professor.
there are new examples because actually during all the course we will do coding. Okay. So if there are examples that are on the top, and we discuss about examples that are on the top of what you already have on eCentennial, I will post them. Okay, so you have access to the code, you will have access directly, because the main problem, first of all, if I record 2 hours, that will be a huge file. Sure, that file is saved on the cloud. It's not a problem. The problem is the fact that you will not be able to have access to the code. All right, so I'm posting the code on a whiteboard. Right, actually it's a Word document, but you have to take line by line, and I'm not so sure we'll be able to do it, and to copy. When I'm posting on eCentennial, you actually cut and paste the code. Okay. The code is secure, it's already tested by me, so you have access directly. In a few seconds you can, copying after a PDF, you have to change few elements because PDF is a format document, okay? And after you'll do that, your code will be without any kind of errors, okay?
Okay, thank you. One last question, really quick, Professor. So sorry. So the week 1 examples and the lab 1 generic and extension methods. The week 1 examples. That's fully done. That code is good. Okay, thank you.
Yeah, you're very welcome. Okay, so regarding Tiane, so you can use without any problem Visual Studio 2019. Okay, so not necessary to switch to 22. It's a good idea to do it, but not necessary. So all the code will work perfectly on 2019. Okay? That will not work. So careful, guys, other guys will not work on 2017, okay? Or older version than 2019. All right. I know there is a problem with installing. So eventually, if you have a limited space on your laptop, if you are using a solid hard drive, that could be a limitation because Visual Studio is huge. It's a good idea to have only one version, right? So you have to disinstall 2019, you have to install 2020, and that will take 22, that will take hours and hours of disinstallation and installation again, so on. Other question, guys? All right, so if there are no other questions, let's take a look a little bit. So yeah, regarding week number 1, okay, for the new guys, that so initially, so again, you have week 1 example that I'm talking about with the guy that just are new enrolled in our course. Week number 1 example, you have the zip compressed file with all the necessary example that you can work with. This is a kind of general presentation of generics, type constraint and extension methods. Yeah, it's something that's very slow today. All right. Okay. So this is a general presentation. You have some examples, some videos. Okay. I again, for the guys that are just enrolled in our course, guys, don't forget the manual. Okay. So you can have access to the manual, which is you can find it online. Is a great manual, but what you have to do the best to understand what we are doing here is to go directly to Microsoft documentation. All right. From time to time, I'm posting some links to Microsoft documentation, and that is the most important thing. Don't forget, we discuss about a language which belong to Microsoft. Okay. So careful, study Microsoft documentation. Okay, so you have examples there. You have a clear explanation of the theory. It's the best that you can do. Okay, do not, because because we discuss about the amplitude of the theory. Okay, do not try to memorize. Okay, don't. You need to remember where you can find the necessary information, right? If you are facing something that you consider that you need to know, you just click on Google, check directly online, and you sure go to the Microsoft documentation, and that will help you know a lot. Okay. I'm talking I'm talking about especially about the first homework that you have to do. Also, guys, you have lab number 1, which is a homework. All right, which is a homework. You have to download and zip it and start working on it. Is due end of next week. So please, please don't forget to work on it. All right, be careful about this. And also you have why generics are important, and generics, you know, what we discussed last week. All right, supplementary, it's you know, my lecture of last week. All right, my last week lecture. Okay, let's jump to week number 2. A very simple overview. Week number 2 examples. It's a zip code. Okay. 1 second, guys. All right, so you have week number 2 example, which is zip file that will cover actually zip number 2. The week 2 example will cover actually week 2, 3, and 4, because on week 2, 3, and 4 we'll discuss about data structure, right? Data structure in on generics. Right, so also you have introduction to data structure, which is cover everything. Sure, you have the you know, the link to Microsoft documentation, and you know, some example you can copy and paste directly the code, and that will be functional. Right, short explanation, linked list, explanation, stacks, an example. All right, collection, the queues. All right, and that's it. So a short summary that will push you to the next week, week number 3, which is hidden to you in this moment. All right. To this moment, there are any kind of questions? All right. Looks like there are no questions. Guys, let's start discussing a little bit about data structures. Okay, so you can find all the necessary information about data structure in the namespace in the library system collection generic, right? That contain interfaces, classes, and define generic collection. Because guys, on the week 2, 3, and 4, we'll not talk generally about collection. We'll discuss about generic collection. All right, careful about this. All right, we'll discuss about generic collection. All right, we start on first week with generics, and now we get a little bit specialized. We are discussing about collection generic. Okay. So system collection generic namespace contain interfaces and classes that define generic collection, which allow users to create strongly typed collection. You know, we discussed last week about what is the meaning of strongly typed collection, that provide better type safety and performance than non-generic strongly typed collection. Okay, so we'll start with again, let's do it like that. Okay, so I'm clicking on my link. So you have the link already on eCentennial, and you have, this is Microsoft documentation, system collection and generic namespace with all the necessary classes. All right, so you have here all the classes. You can study them, you can have access, you can study what are the interfaces, what are the methods, and so on and so on. Okay, good. All right, let's start with the first collection. Right, and the first collection that I will present it today will be system collection class list T. All right, so we discuss about list. All right, list T, list from system collection generic. All right, so .NET framework class library provides several classes, right, used to store group of related objects. These classes provide efficient method that organize, store, and retrieve your data without one second.
You are now muted.
All right. Without requiring knowledge of how the data is being stored, right? So again, these classes provide efficient method that organize, store and retrieve data without requiring knowledge of how data is being stored, right? So you just call the method and you don't care what's going on after that, all right? You don't have to think about the system. It's optimized to do that thing for you, right? And will do it in the in a kind of optimized way, right? That will reduce drastically the application development time, right? Consider that before you used array to store sequences of objects, right? So what is a problem with an array? Do you remember? Right, so I'm trying to build up an array. What is the problem with that? When I build up an array, all right? What is an array? You know, is a sequence of specific objects, right? Right? So what is a problem? Guys, this is a question for you. When I'm using an array, remember? I'm trying to build up an application, you know, to store, let's name it 20 strings. What I have to do? Come on, guys, don't sleep. Come on. Come on. So I'm trying to build up an array. What I have to do? Well, we have to create it, right? We have to create it and all right. No, it's okay. Don't worry about that. And something else. Populate it, but before we populate it, what we have to know specifically? Data type, sure, we initiate, but before of that, before we initiate, when we build up, you know, when we build up an array, what we need to know specifically. Exactly is the dimension, all right? Because we need to declare the dimension of the array, which is a pain in the ass. Consider that we want to build up an array of names of people living in a specific neighborhood, all right? And we consider that we have 5,000 people living in that neighborhood, and sure, we build up the array with 5,000 people. And now suddenly we have a problem with immigration, let's name it, and we have now 7,000 people. What we have to do? Have to build up another array to copy the elements and to add the other 2,000 people. And consider another year passed. Now I have 9,000 people, and so on and so on. That will be a pain in the ass, right? So so that problem is solved by list T. Why? Because list T automatically change their size, execution time, to accommodate additional elements, right? So I build it one time, and I can add more elements over that initial capacity of my list T, right? So I don't have to do it manually by adding a new array and okay. Or eventually using on resize on array class, right? All right, so how I'm name it list T. What is T? T is a kind of a placeholder, all right, which and there I declare the list. I declare the type of the elements that I want my list to hold, right? Well, the way how I'm working with the list is almost similar with working with an array, right? So this is a list one, for example. This is a list of integer, right? So if I'm this is a list of guys. This is a list of what? Come on, guys, wake up, wake up. I know the weather is not great for no, but what kind of list is that?
Hello, Professor, can you hear me?
Yes, yeah, yes.
It's a list of strings.
Oh, list of string, exactly,
Sorry, I've
right.
been talking, but my mic hasn't been picking up.
Oh, no problem. So keep it on, or eventually, yeah. Tiane, all right. So yeah, but we already declared type of the elements, all right? So again, T is a placeholder, all right, and that show me what kind of list I'm creating, right? Is a type of the elements, okay? All right. So classes with this kind of placeholder that can use, you know, for any type of the elements are named generic classes. Okay. All right. Good. Right. So let's see what are some methods, because when we discuss about this kind of generic classes, we have also methods that we can use. All right, on and methods that allow us to work with this kind of classes. So first of all, what should be? Should be a method to add elements to my list, right after I declare it, and that this method add an element at the end of the list. All right, so add element. So I have add. What else you consider I should be? Capacity. That get or set the number of elements in a list that the list can store without resizing. That show me the capacity. Here, right, remove all the elements from a list. Contain okay, so what is doing contain? I'm checking if a specific element is inside the list. All right. So careful about that. So this method do not show me the element. All right. I'm checking, is John in my list? And this, this method return what? Return yes. Yes. True or false. All right. That's it. So this is contain. The one is count. Okay, guys, question for you. What is the difference between contain and capacity? Okay, I'm looking for an answer, guys. The difference between contain and capacity. Actually, between count and capacity. All right, count and capacity. So take a look. Capacity get the number of elements in the list without resizing. Okay. So, for example, capacity show me exactly. Capacity show me how many elements the list can hold. All right, to a specific moment. All right. So, and count show me the number of elements. Now the number of elements inside my list. All right. For example, a list could have a capacity of 8 elements and have only 5 in this moment, and 3 are empty, and I can add more 3 elements without resizing. Okay, without resizing, because if I add 4 elements, the list will resize automatically. Right? Right. Let's take a look to other property. Right, index of return the position of the first occurrence of a specific value. All right, so be careful about that. Is just the first occurrence. For example, an element could be in the list multiple times. So index of will show me just the first one, okay, not all of them. Index of insert an element as a specific index. All right, so index I'm sorry, insert insert an element to a specific index. All right, another one is remove the first occurrence of a specific value. Well, take a look, remove add, right? Remove an element to a specific index. Okay, careful about this. Remove range. Remove a specific number of elements starting with a specific range. Sort. Sort the list. And very nice, because I don't present all of them, just some of them, right? Some of the methods. You can find all the methods. So if you study the document, Microsoft documentation, you will find all the necessary information there and references to all the methods. Trim excess, for example, allow you to trim and sets the capacity of the list to the number of elements in the list that are currently in the list. Okay? All right. Let's run some simple piece of code. Yeah, it's let's open a page. All right, guys. It's a good idea to have your Visual Studio open and to work together on these examples. List capacity. Okay, so guys, let me know if you run the code. So again, it's a good idea to have Visual Studio open and run the code. Okay. So what do you think will be the result of this piece of code? Guys, I'm looking for the result. What will be the result of this? You can do that by analyzing directly the code and yes, yes. Yes, I'm looking. Guys, I'm looking to see what is how. Right. So all right. Okay. Take a look. Okay. Take a look. All right. So initially, the capacity of the list is um, okay. So can it's someone is able to tell me why this capacity is 8 on the second? What do you think the capacity? Why do you think the capacity is 8? All right. Good. Good. All right. Good. We'll discuss a little bit later about that. Okay. So I was curious if someone is able to, or eventually know what's going on, but we'll discuss a little bit later about that. All right. Um, you know what? Let's do it now. Let's do it now. Um, okay. So, how? Um, we already discussed about the fact that every time when we add more elements to the list, to a generic list, to a T list, to a generic list, the list resizes automatically. All right. Let's understand this process first of all. How this because consider that I have, let's name it 1 million elements, and I need to add one more element. All right. So that will be a huge amount of work, right? Recopying everything, making a new list of 1 million, one element, all right? And after a few minutes, I'm adding another element, and now I'm rebuilding everything. I'm copying 1 million, one element, and I add the new element, and I have at least 1 million, two elements, and so on and so on. So that would be a huge amount of time, processing time, right? Well, actually, they found another way to solve this problem regarding, automatic resizing, and the process is like that. Every time when I'm going, the number of elements goes over the capacity of the list, the list double in capacity. Okay, so in our example, I add the first element, and now the list, so the list was made with 2 elements. Okay, so I have 2 elements. I add the first and the second one. Now my list is full. I have a capacity of 2 and count of 2 elements, so both positions are occupied. I add the third element, and the capacity in the list goes automatically to 4 as a capacity, but it's only 3 elements occupied, only 3 elements occupied position in that list. The fourth element that occupies the last 3 position on my list, I add the fifth one, and my list double in dimension, and now it's 8. So this is the reason that the result it's 8. Okay, so again, when I'm adding, so every time when I'm adding a new element over the capacity of the list double in dimension, okay, as a capacity, right? So this is a very important thing, to reduce the time necessary to rebuild everything. All right, let me all right, good. Let's run another example. Well, we already ran with the count because we use capacity and count. Let's run an example with add. So what I'm doing here, I'm adding elements, right? I build up a list of strings. I'm adding elements, right? I'm using add, right, to add elements. And I'm printing my elements, right, plus all in front, okay? That will be add capacity add. Yes. Any questions?
No, sorry, Professor. I'm just
No.
testing
All
my
right.
mic again.
All
It
right.
stopped working.
Okay. All right. Okay. So let's jump to another example. Okay. So another example with list here. Right. So another example with clear. So I'm adding elements, and now I have the capacity. You can guess what is the capacity, and also you can guess what is count showing me. And after that, I using clear and sure I'm deleting. Careful about what's going on, right? Because now I'm showing the capacity and I'm showing the elements, okay? So what do you think? So here it's clear my data capacity, what will be? 4. Count will be how many elements will be 4. Now I'm clearing everything. The capacity will be, and the count will be, I'm looking for your answer, guys. Nope. So, Ashley, careful. So, now, so I add 4 elements, all right? And I suppose you already understand how the class is built, right? Is the capacity. Take a look. Well, April, you're close, all right? But so take a look. I built 4 elements. Think about power of 2, all right? So I have a list of how many elements? 4 elements with a capacity of 4. No, 6 is not power of 2. Double doesn't mean right? Double doesn't mean all right, okay, all right, okay, no problem. So think about that. I add these elements and now I have a list of 4, right? I have a list of 4 and the number of elements will be 4. I'm clearing how many elements I will have. So I clear the list. How many elements I have in the list? 0. Perfect.
With 0, yeah.
Right. And what will be the capacity? Guys, Mark, you are close. All right, let's make it with a pencil. All right, here capacity is, take a look, write capacity, my data capacity, how many elements I add? 4. All right, so that will be, the result will be, here will be capacity of 4. Okay, now count, I'm counting, right? Capacity is 4. How many elements I have in my list? Again, that discussion. Yes is before clearing. Yes. So 4, perfect. The next will be 4. Now I'm running clear. I'm running clear. All right, I'm running clear exactly here. And now the count. So I leave a place for the count. What will be, how many elements I have now after I clear? 0 elements. All right. And what will be the capacity? 4. Perfect. This is the idea. All right, because the list remain as a capacity. Now I have 0 elements. Exactly. Right. So, all right. So clear doesn't destroy the list, just clears the elements inside the list. If I have a list of 2 million, now I will have a count 0 after clear. I have 0 elements, but still I have 1 million elements, 1 million places to put a new other elements in the list. Okay, so clear do not destroy the list. Okay, the list doesn't resize, doesn't shrink. All right, careful about that. Good. What I'm doing here. All right, we discuss about that. Let me check. What else? All right, we already continue. All right, let's do something with contain. All right. This is a little bit all right, so what I'm discussing, so I build up a list of string with arguments, right? Now, what I'm trying to remember what we discussed about contain, return true if the list contain a specific element, and false otherwise. Okay. Well, this is a little bit complicated, a little bit tricky, because I need to compare a list with arguments. All right. So is a list that show me, because take a look, all these boxes are the same, but actually the dimension differ, right? So I have what I have to do, I have to define this, right? Okay, so let's destroy that because we don't need it anymore. Okay, so I'm using contain, right? And that contain will check if this box with these parameters exists in my list. Otherwise, I have box can be added. All right, and I'm building this class box, right? E-equitable. Well, E-equitable is a kind of is a I'm replacing E-equitable. It's equal with, it's the same as equal, right? Or the same or lambda parameter. Okay, but I'm using E-equitable for generic classes. All right, so here I'm declaring, right, and I build up this class box, all right, where box, and here I define the parameters, right, and this is a condition that gives me that return true and false. Hi guys. Let's run it together. Okay. What is the return? The return is an equal box. It's already in the collection. Okay, so I have here the return. Okay. So we play a little bit with list contain. What other? Contain, count, okay. Count, index of. Okay. Let's build something with index of. Yeah. Okay, guys, it's all right. Oh, okay. This is the call. All right. Let's jump to a new. Right. So that was on index of. Um, okay. Let's using set. Okay, so guys, I need your analyze over your over this piece of code, please. Yeah, sure. Alireza, sure.
So you've created a list of string type variables that the list is called words. Then you're inserting into that list at position 0, you're inserting a letter A.
What is the position 0 is the first, right? Is the first element in the list, right? Because I cannot insert it, right? Well, I can, but the position, I should occupy the first position, right?
Yes.
All right.
Generally, well, I mean, it depends on how you want to handle it.
Right. But now I insert it at start, all right? Because I insert it as position 0. Okay.
Yeah, and then you loop through the words list, and for every string you write to the console or plus the value of the string.
Exactly. All right. Great. Okay, let's jump to a new short, very small piece of code that we play with. Insert. Right? Remove. Let's try for remove. Oh, I'm sorry, this must insert. Right? Okay, so let me check. Okay, that will be out. Okay. Okay, remove. One open. Right? Yes. 1 second, guys. I need to build something that have all the necessary elements. Right, so let's go on. Fine. Right. Alright. Okay, so I need to run it again. Right. This is good. Alright. Oh, okay. Run it again. And this is out. No, it's okay. All right. All right, let's play a little bit with remove. Okay, so let's so um, all right, so what I'm doing here, all right, so what I'm doing here, I'm creating the list, and right, I'm checking what is now the capacity and the number of elements. All right, now I'm removing a specific element in the list. Right, again, I'm checking the capacity, I'm checking the annual number of elements. Here I'm removing the fourth element to add, right, at the position 3. Why is the fourth element? Because the first element occupies the position 0, right? And here I can do it like that, and that will remove, okay, a range, right? So we have a simple example with remove, add, remove range, right? 3 different methods, right? Remove range, starting from position 0, the first 2 elements, okay? And sure, I have now that the system will present me, the capacity and the count. Okay? Good. Another example. Something else. Remove range. All right. Let's do something with close this and all right. Let's try and let's just something simple. Right, so this is a simple example with trim excess. Okay, this is the last one from this bunch of small example that I want to present today. So it makes sense. So we have a small problem here. Input, okay. Get range. My data getting, my data makes sense. We're consider my data. This is close. All right. All right. So now let's jump to another example. So guys, I'm looking for your participation. All right. So someone is able to analyze the code and to tell me what's going on here. And what could be the output?
So you creating a new list and then you counting the capacity and count before you've added anything. You're then adding the color red without an index and the color yellow with a 0 index. I'm not too sure what had happened there. If you insert red without an index, does it automatically default to 0?
Right, right. And after that, you insert
yellow.
Right.
So I'm not sure if you're going to now overwrite your red value or something? I'll have to test that, but
Right. So will it be yellow or red? Okay.
So let me ask this, Professor: is
Yeah.
a list always going to be indexable or traversable by index?
So the list. So initially you build up the red. Initially you build up the list and will be at red at the position 0. Right. Make sense?
Yeah.
All right. After that, what's going on? I'm forcing, pushing yellow to the position 0, right? Because now I'm indexed, I'm inserted with index. All right. So yellow will go on the first position, and red will be um, um, on the second one. Okay. Okay. Right. Yellow or red. Okay. Right. Perfect. Perfect. So what's next?
So now you use a for loop with a counter to display the items in the list. Then use a for each loop to display the items in the list. Then you add green and yellow. So green would be index 2, yellow would be index 3. Adding 2 elements. Now your count would be 4. I think your capacity would be 4 as well.
Yeah, sorry guys, I was talking with myself. Yeah. Um, okay, so what I'm doing here, I'm adding green and yellow. All right, I'm adding green and yellow, and now I have my list. Now I have my list with what? With yellow, red, green, yellow. All right. So yellow, red, green, yellow. Okay. Now I have 4 elements in the list. Okay. Now I'm removing the first instance of yellow. Actually, it will be the first one, right? And now my list will look like. Now I cut the yellow. I have red, green, yellow. That's it, right? What else? Um, Guys, you should be able to find all of this. No, I'm not, because you should be able to find everything on eCentennial, all right? So not necessary, because here we just discuss about the um, this code, all right? You will not be able from eCentennial. You will be able to copy and paste the code, okay? So it will be very easy for you guys. So after I remove um, um, right, so I remove yellow, which is the first instance of yellow. Now I remove add and position 1, all right? But don't forget my list is, um, um, so without yellow will be red, green, yellow. Now position 1 is green because red was on position 0, right? So position 1 is red, and I remove at position what? Position 1, which is green, and now my new list is red and yellow. Okay? What else I'm doing? Yeah, I'm checking again, count and capacity, and I have 2 elements and the capacity of 4. I'm checking if my list contain the element red. Okay, so I have 2 options, not or yes, right? Adding more elements, 4 elements. Now with another 2, I have 5 elements. So again, here counting count and a capacity will be what? 5 and 8, and that's it. Okay, so everything is run properly. All right, so I'm checking what are the elements in the list. Here I so to this 2, I add the other elements. Now capacity 5 and 8. The elements now red, yellow, orange, violet, and blue, and that's it. Okay. Good. I think you already have on Centennial this example. Okay. All right. Okay. Okay. let's run another simple example. Very quickly. Well, now we are discussing about objects. So this is an example from Microsoft. All right, so yeah, now we discuss, all right, discuss of objects. Okay? Discuss of objects that have, different parameters. Now we have a part name, we have a part ID, so we discuss about two parameters that define each object. What is this? What is this? Alright, I need to, because my computer is not able to support. Let me save. I'll try again. Looks like my computer have a problem in this moment. Alright. Guys, you already have all these examples you'll find these examples on his Centennial, all right? Looks like I have a problem with my computer. I'm not able to yeah, looks like we close also that one. All right, let's try again. 5. So guys, you'll be able to find this on Microsoft documentation. Okay, is a nice example because it's working with complex elements. We start to work. It's working with objects. Otherwise, so a list is built. Some elements are added to the list. What else? We are testing the capacity. All right, we are we check contain if a specific part is inside. All right, and so on, so on. All right, so also we are using remove add to add more elements. Okay, so again, check Microsoft documentation and you'll find this this very nice example there. Okay. Okay, so we'll close here. I need to run to another course now. So guys, if you don't have any question, so do you have any questions for me? Don't forget about final of the week. Final of the week. We have now due date for your assignment. Okay. Tiane, take a look. So on introduction to data structure, all right, you have system collection generic. All right, system collection generic. Click on it, and you have I click on it, and I have access to Microsoft documentation. Okay, the example was related with list. All right, list T. Okay, list T. Take a look. You have here the example, okay, with and also the explanation. Okay, good. Well, are you in Canada? So you should be able to connect. Okay, take just maybe the link doesn't work directly from should work directly because it works for me, but otherwise just take the name system collection generic and comma Microsoft, and you will be able to, on Google, and you will be able to connect. Okay. All right. All right. Okay, guys, I have to run to another course. All right. Have a nice week ahead. For any other question, simply send me an email. Okay. Have a nice evening. Have a nice week ahead. And again, don't forget, end of the week is a due date. It's Friday. All right. Friday is a due date for the homework, test number 1. Okay.
Thanks, Professor. Have a good one.
You're very welcome.
Have a good evening, Professor.
Have a nice evening.